Hello. So today we are going to talk about combining like terms. And we're going to start off with some definitions. We're going to do some practice together, and then you're going to do some independent practice. So starting off with a definition, like terms are terms that have the same variables and exponents. So I'm going to give you some examples and some non-examples as well. One example would be something like 2x and maybe like negative 7x. So they have to have the same variables. Remember, that's like the letter. So x and the same exponents. We might be thinking, I don't see an exponent. But remember, if we have an x or a y or a z or whatever variable, there's an invisible 1. So this is really like 2x to the first power, negative 7x to the first power. And one of the important parts that I want you to remember is that the coefficient doesn't matter in terms of when we're talking about like terms. So the coefficients here are the number in front of the x's, the 2 and the negative 7. They can be negative, they can be positive, fractions, decimals, doesn't matter. The only thing that matters is that they need the same variables and exponents. So let me give you another example. 4y and how about like negative a half y? The variables are both y. They're both really y to the first, even though it's invisible. That there's, that exponent of 1 is invisible. The negative 1/2, the coefficients, they don't matter. Let me give you another one. How about this? A squared b and 5a squared b. Those are like terms because the variables are a squared b. Now the coefficient of my first term here, there's nothing written in front, but really there's like an invisible 1. So it's like 1a squared b. Let me give you a non-example. What if I had like negative 3x squared y and 10xy squared? So I see like a squared, I see an x and a y, but they're not exactly the same because in the first term we have like x squared y. In this term we have x y squared. So these are not like terms. That would be a non-example. All right, next definition. Standard form. Expressions should be listed in alphabetical order with descending powers. Here's what I mean. When I have a bunch of terms, let's say I have like 5x plus 3y minus z plus 10. These should be listed in alphabetical order. Notice x, y, z. And then this term, this 10, it doesn't have a variable. That's what we call a constant, and the constants always come last. And you might even want to make a note. Constants come last. That's always true. So you're always going to have your variables and then your constants at the end. So they're either going to be alphabetical if you have a bunch of different letters, a bunch of different variables, or you might have all x's or all y's or all a's with different exponents. Descending powers means the biggest exponent has to come first. So, for example, if like 7a cubed plus 12a squared minus a plus 1. Remember, the coefficients don't matter. That's the 7, the 12, the negative 1. There's an invisible negative 1. What matters is the exponent. So in this case, my exponents are 3, 2. This is going to be an invisible 1 here. And then my constant is always what comes last, right? Okay, so now we know what like terms are. We know what standard form is. Let's do a little bit of practice with just those two words. So put the following terms in descending order, or in other words, like standard form. So I'm going to look at the exponents here. My exponents are a 5, a 2, an invisible 1, and that negative 8 term, that doesn't have an exponent, or a variable, I should say, sorry. That doesn't have a variable, so it's a constant. Remember, that's always going to come last. So my biggest exponent is going to be that 3x to the 5th. I'll cross it off so I remember I've used it. That negative 2x squared, remember, only the highlighted exponents are what matter. and then plus 5x, and then my constant always comes last. So that is descending order or standard form. All right, number 2, again, look at those exponents. A squared, a to the first, a cubed, another a to the first. So we'll talk about that in just a second, but the biggest exponent is this a to the third. So negative 2 a to the third doesn't matter the coefficients, the number out in front, the negative 2 or the 6. Only matters the exponent. So this 6a squared. Now these next two terms, 6a and a, let's think about them. They both really are like a to the first power. So it's kind of like they're tied. How do I know which one comes first? Well, neither one of them should come first. If they're tied, if they have the same exponent and the same variable, they're like terms. And what we're going to do today is we're going to talk about how do we combine them. And the way we combine them is we're going to actually add the coefficients, which we'll get to kind of more formally in just a second. But think about it this way. If I have 6 A's and 1 A, because this is really 1 A, think about like I have a pile of 6 pencils and then 1 pencil, and I add them together. I have 7 pencils, right? Or in other words, 7A. So there you go. That's your final answer there. All right, next part. Let's talk about which of these are like terms. So remember, like terms have the same variables and the same exponents. So my variables, I'm going to start with this first term, are a to the first power, b to the first power. In other words, there's like an invisible 1, right? If I go through, this one's like an a to the second. That's not a like term. This next one, oh, here we go. A to the first, b to the first. This next one has a b squared. That's no good. B squared. And then this one has an a squared and a b squared. So let me start with the 8ab and the 12ab. If those are like terms, I might want to circle them. Now let me go back to this second term. A squared, negative 4a squared b, right? Well, I circled these ab terms. So maybe I want to put like a cloud around like the a squared b. Do I see another a squared b's? This term here, this is like ab squared. That's not the same thing. This one's not the same thing, and that one's not the same thing. So this negative 4a squared b, that's the only thing that's going to go in that cloud. Uh-oh. Hold on, let me get that back. Sorry. Oh, no. Oh, no. Here we go. We're back. Okay. So we put a circle around these, cloud around this. That's the only a squared b. Now let's get to this negative 3ab squared. So ab squared, maybe I'll do a heart around those terms. This 2/5 has an ab squared as well. So I could maybe do a heart around that one also. And then this last one, a squared, b squared, I don't have any other terms that are a squared, b squared. So that's kind of like on its own. Maybe I'll do a triangle, or I could do a square, or whatever. So those are my like terms. All right, let's put this all together and talk about how we combine like terms. First step, we identify all of our like terms, kind of like what we just did. You could do hearts around some, clouds, whatever. And then we're going to add or subtract the coefficients of those like terms. But here's the part that people mess up often. Keep the variables and the exponents the same. And I'll show you what I mean in just a second. But you might want to underline or highlight that because that's the part that people kind of forget. And then step 3, write your answer in standard form. Remember we said like alphabetical, if you have more than one variable, more than one letter, or if you have different exponents, the biggest exponent comes first. All right, let's try some examples. Number 1, we're identifying like terms. So like terms, same variables, same exponents. So I have like a 3a and a 4a. Those are both like terms actually. Now to combine like terms, Remember we said we're going to just add the coefficients. So the coefficients are the numbers in front of the variables. That's that 3 and 4. So you're literally just going to add 3 plus 4. We get 7, right? And remember I told you the part that gets easily mistaken that you need to like underline or highlight is that the variable and the exponent stays the same. So it was both terms that were a, just a, or in other words, like a to the first power. So my answer is going to be a, or a to the first power. And then that's it. All right, number 2, look for your like terms. I have like a b to the first. I have a b to the first. I have a b to the first. These are all like terms again. I'm just going to add the coefficients. The negative 12 plus 6 minus 4. And you can use your calculator for this, right? Negative 12 plus 6, that's going to give me negative 6b. And then negative 6b minus 4b is going to give me negative 10b. So adding them all together should give me negative 10b. And again, I added or subtracted the coefficients. I kept the variables and the exponents the same. Let's look at number 3. I have a couple n terms, or like n to the first, and then I have some constants, some plain old numbers. So I am going to combine 2 different sets of like terms, like the squiggles and then the circles. But here's what you need to remember. Your answer is going to be in standard form, or in other words, like alphabetical or descending order, right? So I'm going to combine this kind of like 2 steps in one. If I have n's and constants, I know my n's are going to come first. So I'm going to combine those n's. So this is really like a 1n. So 1n minus 5n, negative 4n. So I can even cross these off if that helps me keep track of like what have I done and what have I not done. And then I have the 4 minus 9. 4 minus 9 is negative 5. Now my answer is in standard form. So I'm good. That's it. Okay, number 4. So we have lots more terms here. This might look a little intimidating, but we're just going to break it down one step at a time. We need like terms. So first term I see is a 5a squared. I'm going to go through. Do I see any other a squareds? Remember, the coefficients don't matter. And then I'm going to go back. I had like a negative 6a. So here's all my a terms. And then I also have some constants. I have, oh, why'd that get like that? I have a 7. I have a negative 2, right? So those are my constants. So now I'm going to combine like terms. But again, keep in mind, in my answer, if I want my answer to be in standard form, which one would come first? The ones in the circles, the a squareds. So 5a squared plus 7a squared, I need to add 5 plus 7, and that's 12a squared. And again, I can cross these off kind of as I go. Next term should be the a terms, right? Negative 6a plus 3a plus 8a. So I'm going to start with the negative 6 plus 3. That's negative 3. Plus 8 is 5. So this will be plus 5a. So I got rid of all these. Now those hearts, negative 2 plus 7, that's plus 5. And notice, double check, my answer is in standard form. Like the a squared comes first, then the a, and what comes always last is my constant, right? Okay, number 5, let's find like terms. I have a cubed b. So I have 3 a cubed b terms, right? Let me go back. This is a squared b squared. And then I have this kind of like leftover one. I could do like a triangle or something like that. Okay, remember again, before I think about combining, which term's going to come first in my answer. So I noticed that in all of these, like I have an a and a b. I need the highest power to come first. But this one's tricky because like I have like a squared, b squared. So in this case, you would look for the a cubed. The a cubed, that 3 is the biggest exponent, right? So I'm going to combine those a cubed b's. And I got, so in other words, the ones in the circle. So 3 minus 7 3 minus 7 is negative 4, right? Negative 4 plus 10, that's going to be 6a cubed b. So boom, boom, boom. And then I'll go and do my a squared b squared. So the squiggle ones. I have 4 minus 5, so that's negative 1a squared b squared. And then finally, I have my plus 2ab. Now, I want to take this one step further. I want you to think about this for one more second. We really don't write the 1 as the coefficient. So we want you to kind of, you can like write this down at first, but we want you to get out of the habit of writing that 1 if that's the coefficient. So I'd love for your answer to look like this. 6a cubed b minus a squared b squared plus 2ab. So I'd love for your final answer to look just like that. Okay. So, where am I? There we go. Sorry. Having issues moving to the next slide. So, okay. Here are some practice problems, 6 practice problems. What I want you to do is pause the video right now, and I want you to try these practice problems on your own. And then when you unpause the video in a couple seconds, or in a couple minutes, excuse me, when you unpause the video, I'll give you answers. You can check everything that you've done, okay? So pause now and try these problems. Okay. So here are answers to all 6 of those problems. So take a minute, check your answers, make sure you got all these correct. And if you did get some incorrect, see if you can figure out where you went wrong, where you made your mistake, and feel free to even rewind this video and kind of rewatch some of the sections or some of the example problems if you want to. So now that we're good at combining like terms, let's do a quick distributive property review. Now, hopefully you remember the distributive property really like means multiply. So example number 1, if I have that 5 written right in front of that parentheses, this really means 5 times everything in the parentheses. So in other words, you're distributing the 5 or multiplying the 5 to everything in the parentheses. So 5 times 3x is 15x. 5 times 4 is 20. The additional piece I want you to remember is that nothing else can be simplified, but I need to think about my answer. Is it in standard form? Is it in descending order or alphabetical order? In this case, yes, it is. All right, number 2. So this means 4 times everything in parentheses. So we're going to distribute the 4. 4 times 7, 28, right? 4 times negative 6, or I'm sorry, negative 6x, and then 4 times 8y. Okay, so now I did my distributing, great, but I need to make sure my answer is in standard form. Descending order or alphabetical order is what that means, right? It's not. I need this x term to come first, then the y, and my constant, remember, is always going to come last. So it's negative 24x plus 32y plus 28. So now this is in alphabetical order, like x, y, constant, right? And also I want you to keep in mind, the 24 was negative to begin with. So when I write that term in front, I need that negative. This 28 that was out in front, that was a positive. So when I write it in my answer, there's a plus sign in front of that 28, right? Okay, let's try the third one. So now in the third one, I just have a negative out in front of the parentheses, but really that's like a negative 1. So I'm really just distributing a negative 1. So negative 1 times 3x, negative 1 times 7, and negative 1 times negative 8. And then again, I think about my standard form. My x term should come first, but now I have some stuff that I can combine. I have some like terms. So there's my final answer. Okay, so just like before, here's some practice problems. I want you to pause the video. Again, if you need to rewind the video, rewatch at any point, whatever. And then when you unpause, you can check your answer. So go ahead, pause the video. Okay, so now that you tried these 3 problems, here are your answers. So check these. And remember, you're distributing, but then you're not just distributing, you're making sure that your answer is always, always, always going to be in standard form. So from this point on, every answer you write has to be in standard form. All right, last but not least, let's put this together. So we're going to use distributive property and combining like terms together, but I want you to always keep in mind, always, every time we simplify, we're following the order of operations, PEMDAS. So P, we're simplifying inside the parentheses if we can. Negative x plus 4, those aren't like terms. I can't simplify. So P, I don't have anything to do. E for exponents, no exponents to simplify. M or D from left to right, multiplication or division. That's where this distributive property comes in. This means 3 times that parentheses, so I'm going to distribute in, right? So this is negative 3x plus 12. I'm just going to rewrite and bring down the rest of those terms. And now the only operations I've left are addition and subtraction. So here's where my combining like terms is going to come in. I notice I have a bunch of stuff to add and subtract, but some of them are x's and some of them are constants, right? So I'm combining like terms. I'm going to add the like terms. So negative 3x plus 6x is positive 3x. And then positive 12 minus 2. So my final answer, again, is in standard form, descending order, alphabetical order. So 3x plus 10. Okay. Number 2. So number 2, a common mistake. I think a lot of students would look at this and be like, oh, I should add negative 2 plus 4, right? But here's the thing. That's actually not what we want to do because PEMDAS tells us we should look to simplify in the parentheses. So in this parentheses, I don't have anything I can simplify. Exponents don't have any, but then I should multiply or divide first. So 4 parentheses, that means 4 times. So I actually don't want to add this negative 2 plus 4. I want to distribute this 4 to the parentheses. I'm just going to bring this negative 2 down. I'm just going to recopy it. And then I have 4 times y is 4y plus 4 times 3x. And then 4 times negative 5 is negative 20, right? So really my first step here is that distributive or multiplication. Now my like terms, in this case, I really only have one x term. So I'm going alphabetical, one y term, and then I have my constant. So 12x plus 4y. Now I got to combine. The only things I have to combine here are my constants. So negative 2 minus 20, negative 22. All right, last but not least. So again, P for parentheses inside the parentheses. There's nothing I can do. No exponents, multiplication or division. Okay, my multiplication, I have this 3 times that parentheses. That's multiplication. Or actually negative 3, sorry. So I'm bringing down this 6x, just bringing that down, and then I'm distributing. Negative 3 times 3x is negative 9x. Negative 3 times 7, negative 21. Negative 3 times negative 9 is positive 27y. And then plus 2y at the end. Okay. Now I have to get rid of, or I'm sorry, I have to combine my like terms because addition and subtraction, these are all pluses or minuses, right? So that's my next operation. Now, this is kind of nice because my x's are right next to each other and my y's are right next to each other. That doesn't always happen. And then my constant is by itself. So alphabetically, I would combine 6x minus 9x first. And then I would combine my y's. So 27y plus 2y. 27 plus 2, 29, right? And then my constant is always going to come last. There we go. Okay, so just like we have done before, here are some practice problems. Again, pause the video, try these, and then I'll unpause it and you can check your answers. All right, here we go. Here are your answers. Keeping in mind, we're following PEMDAS, following order of operations. So making sure that you're multiplying before you do your adding and subtracting, especially with something like this right here. We do not want to subtract that 7 minus 2 because that would be subtracting before, I'll make this blue, before multiplying, right? Because really this means negative 2 times. And PEMDAS tells me I have to multiply before I add. So I got to do that blue. I got to multiply. I got to distribute before I can add. All right, that's it for today. Thank you so much for watching. Enjoy your day.